You have your homework and your colored pens ready to go, true? I see exponential decay. What do you see? Right? Half-life, 1599. What do you do with that? All right, guys, what's stressing out about?
It's worth 5. 68.5. That's minus 1.5. How do you lose 1.5 on every?
I don't know.
Are you sure it wasn't 67.5?
I'm positive.
Show me when you bring it to school, and then we can look at it. Yeah, we can be confused, but we don't have the test, so let's just let it be. Y over C, isn't that the ratio? Like the percentage of what's remaining, right? So if you have 20 and you had 10, you have 200%, or double of what you had. If you have 5 and you had 10, you have half of what you had. This is kind of like a ratio, right? So can't I say half-life? Just make the ratio 1/2. Oh, wait. When is the ratio 1/2? When time is 1599, true? Which will end up being ln of both sides divided by a negative. We actually end up getting ln of 2 because it's negative ln of 1/2. You can bring up the negative, which is why in a lot of sciencey type classes they just have you memorize the constant of proportionality for half-life and doubling being ln of 2 over t. Right? Isn't that the thing you memorize? Well, but the nice thing is the math gets you there. Like you don't necessarily need to memorize it if you understand the math. Just in a lot of science classes, not many people understand the math. No, that's reality. In my stats class in college, the poor science people sat in the front and were like, and the math people were in the back like goofing off or skipping class, and we were fine. Anyway, it was cute. But then if you tried to ask any of the math people, no clue. So, they asked me, that's K. Ooh, isn't that like a ratio? So couldn't we do like Y over C times 100%? Like move 2 decimals, whatever that decimal is. So after 50 years, all I have to do is come back here and say, okay, cool. So I want the ratio of what's remaining after 50 years. I know my K is ln of 2 over 1599, all times 50. Plug and chug, you'll have a decimal. You'll move the decimal places to the right, and then you got it, right? Double check my math, though. I'm trying to find a working calculator so I can collaborate with the 1, maybe 2 of you that actually has their calculator in class. Which, in your defense, we haven't really had to use it much, right? Divided by 1599 times 50 on the exponent. I'm getting 97.9. You guys agreeing? I mean, technically, if we were doing like AP style, I guess 97.856. It was technically 0.9785, but we moved the decimal places 2 to the right. Division 59 times 50, and then. Wait, how does that make sense? Logically, we're logical people. How does that make sense? There's still 97 point whatever left over after 50 years?
It's only like a small percentage.
Right, because it's cutting in half after 1,500 years. Well, 1,600 years, right? So logically, no, that makes sense. There's going to be a lot of it left after 50. And exponential decay. I don't like that one as much. It's going to decrease and then it's going to level off, but that's not going to help you guys with the concept. This leads us into last night's homework, I think. True? Huh? What's your question, Kathy? What's up, kiddo?
I was just wondering, couldn't you set it up with the machine, like if you were to put like either 1/2 over 1,599 equals x over, like would that still get the same answer?
That's if it was careful. The rates are proportional. The rates are proportional, but the amounts are not. I'm thinking setting up proportion only works if it's a linear relationship, but since this one is exponential. Did you try it though? Because you could do 1/2 over 1599 equals x over 50, so you would multiply 1/2 divided by 59 times 50, right? So you'd have 0.5 times 50 divided by 1599. Could you subtract that from, no, that should be how much is left. Or is it how much is gone? Because then if you do 100 minus that, looks close. No, it doesn't work. Sorry, kid. The reason being is when, like even with similar triangles, that's when we tend to set up ratios. Hey, related rates, an area they try to trick you with proportions of the water or whatever. We can set up proportions with those because the relationship is, can I say linear, constant? The relationship is constant. In this one, the rates are proportional, but the original quantities are not. So good question, Kathy, as far as the proportional. That's what the derivative is, not what the original quantity is. And that's seen by the exponential growth. It's not linear, so that's why I have to say no. Guys, did you come up against Newton's law of cooling in homework? What did you figure out all these different letters stand for? Little t is time. What's big T? Temperature of what, though? Just normal big T. I think it's the temperature of the object, and T sub S is the temperature of, is it the surroundings? Is that what S stands for? So like you have something, Newton's law of cooling is something is being placed in another atmosphere, another temperature. Like if you're pulling like a biscuits out of the oven. It's a very AP-ish type scenario. If you're pulling biscuits out of an oven, then they are a certain temperature as they come out. They're entering another environment, which is like what? Maybe like, oh, this one is 60 degrees. And of course, cooling is going to happen. But how is it going to happen? Oh, according to Newton's law of cooling, of course. Isn't this a derivative? That is constantly proportional? Or that is, I should say, directly proportional to? So does it make sense why we would have some sort of exponential decay going on over here? Interesting. So let's go ahead and check our answers on homework and see how we did. You guys have a Newton's law of cooling. If we need to, we'll come back and talk about how to not manipulate, but how to work with either the differential equation or the original as far as what's going on with the temperature and decreasing. T sub 0, you guys know that one too, right? That would be the initial, that would be the surface, the surroundings, and this would be the current temperature of the object. Wait a minute, isn't this a constant? And isn't that a constant? Interesting. Okay, section 7.4, number 2, final answer is square root of 25 minus x squared. It's a semicircle, which maybe you were able to tell up here with x squared plus y squared equals 4c. Why does it give you an interval? Pourquoi? Yeah, or you just did it ask you? I actually don't know. Oh, okay. I was going to say it could just be reiterating the natural domain of a square root. Number 6, what do you have to do to the cosine squared? Yeah, 1 over cosine squared is secant squared. Aha! That has an integral of tangent. Tricky, tricky. Tangent inverse, but, oh, we had to get y by itself. Well, make sure you know how to. Okay. Well, it depends. What were the directions? Actually, I have it open. What page is this on? To solve the initial value problem, you would need to get y by itself. Sorry, what page? 364. On the AP, though, they're really nice in that they usually say solve for y equals f of. Like they tell you get y by itself without telling you. Does that make sense? But yeah, you guys just read the directions. Sorry, let's keep going. Initial value problem is asking for, given this information, get y by itself, sadly. It's kind of implied. No reason to be sorry. Number 10, did you guys rearrange correctly? Did you do integration by parts or u sub? U sub, you didn't need integration by parts. There's an ln, but there's also a 1 over x. Your du works quite nicely. But integration by parts, I actually tried it both ways. It works too. Oh dear, why is that an oh dear? Final answer, y equals ln of x all to the 4th. Ln of x all to the 4th. Careful, if ln of x is raised to a power, you can't just go bringing down. That has to be inside the ln, not outside the ln. Common mistake. 0 to infinity because ln is restricted. 22 you guys can check, but didn't you already know where it was going to go? It was going to go to exponential decay. And they gave you a hint about the half-life? Is that what's going on? Sure. Let me freeze the screen real quick while I pull up 22. That way if anyone's still grading, you can keep grading. Oh, super similar to what we just did. They said isotope of Neptunium. How do you say that? Neptune, but with an eum? Neptunium? Anyway, it has a half-life of 65 minutes. Much different than 1599 years. Anyway, when they gave us the differential equation of negative ky, they're telling us basically exponential decay. So they give us the half-life 65 minutes, which is where or how they were able to plug in. Because the ratio, once you get your exponential decay, oh, they did it with the rate. Oh, they didn't actually give you an initial, did they? Yeah, they didn't give us an initial. So you would instead just want to use the ratio of 1/2 like we did in homework when we did this one. This one I didn't use the differential equation. I went back to the beginning, but it solves the exact same way. So that's what I would have done. Do we have any more evens? Oh, yes you do. Let me give you a second. There's a lot going on in this one. But he is our, no he's not, our last even. Oh dear. There's one more even, but I think he has like an A, B, C. It's going to take a little bit of time. But number 34 looks like a really good question. I'm glad I assigned it. Go me. Final answer is 1250. I think they were just asking for the initial. Oh, no. Oh, because they did it one way, and then they said, hey, by the way, you could have also figured it out by. That's what's going on for the latter half. But I think the final answer is the initial 1250, right? And then number 34. Beep, beep. When approximating with a tangent line, concavity. Because tangent lines, if I have a concave down portion, where a tangent line is always going to skim? Above. If I have a concave up portion, where a tangent line is always going to skim? Below. Now we approximate with more than tangent lines. That gets rough when we start talking about Riemann sums or Euler's method. Oh, those are still tangent lines. You could do over and under approximations with Euler's method using concavity. Ooh, look at them, BC. But yeah, tangent lines, we always look at concavity. The other hard one is it Riemann sums? Oh, no. Something later that we haven't done yet. Has another approximation technique that we should think about. But guys, there's also a C, right? Letter C is solving the differential equation. Did you guys end up with, after plugging in to find C, 900e to the 0.04t plus 300? Well, how did you get 12? Oh, well, there is 1200, but when you plug in, you forgot to subtract the 300, I think. Maybe? Yeah. What did I say yesterday? We're not that far behind as far as the last edit. That wasn't the last time I accessed it. So that's a little bit different. So that was before. But yeah, we are about a week behind. Okay, do you guys have any questions on the odds or evens that you want me to put on the boards for section? Where was Newton's law of cooling? Did I give you an odd for that? Huh. Anyway, any questions that we have? Yeah, Hannah. Right when we get back. Not Monday, but probably Wednesday. Tuesday or Wednesday.
Yeah, I feel like we always get hit with like a calc test right before our break.
No, yeah, I was supposed to have a test in AB and BC and honors pre-cal right before Thanksgiving break, and not a one of them is going to get their test in. Yeah, it's fun. Pre-cal's ahead of schedule. Go team. But that's why over break you guys are going to have a very different for calculus assignment. Anyway, any questions? Odds or evens? Going once, going twice. Oh, Sally, go ahead. Thank you. 30. Number 7? Number 7, that was you too, Justin? Anybody else besides number 7? Or anything else? 37? Yeah? Well, we can still throw it up. That's all right. People get participation. No memorizing. It was just showing you an application that I thought was practical, but just not an AP calculus test. Anything else besides 7 and 37? All right, who wants it? Starting with people that didn't take one yesterday. Zip, 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 zip.
Yeah, 37.
Okay, you two take 7, and then Justin, do you have 37? Do you want a person to work on it with you? Who has a calculator? You can, Sally, go with Justin. That way Sally can get a point too. And she can be your calculator person. All right, for the rest of you guys, I'm going to have you start taking notes, and then you can switch roles with the people up at the front. Ooh. Yeah, let's go back.
Okay, so since the fact that this is addition,
Partial fractions. Partial fractions. Okay, notes open.
I meant to say, I got this part.